I would like to welcome all of you on this online session. My name is Kristóf Iván. I'm the Dean of the Faculty of Information Technology and Bionics at Pázmány Péter Catholic University. And I will talk a little bit about our Info-Bionics Engineering Master Program. Let me open the slides. So let me talk about the Info-Bionics Engineering Master Program, our two-year master program that we start in every semester, basically. And we are waiting for individuals who are interested in this exciting field of research and development. A couple of example technologies not done by us, but exciting news from all around the world that you could see and maybe get a slight idea on what this interdisciplinary field is about. So brain-computer interfaces, automated EEG processing chip, mind reading or similar technologies. Of course, these are slightly fancy approaches. Also rehabilitation, robotics, exoskeletons, or prosthetics that are really exciting from both the biological point of view and both the engineering point of view. What are the possibilities around that? Both the exoskeleton for rehabilitation and also industrial applications can be seen as a possibility in the future and already in the present now. So if you're interested in brain-computer interfaces, artificial prostheses, neurobiorobotics, the cybertron race, please read up on that. And in rehabilitation engineering, medical imaging devices and their possibilities in multimodal imaging, neural network modeling, or any other complex system modeling, epidemiological models like COVID or similar epidemiological models, complex cellular processes like protein-protein interactions, state-of-the-art research tools. So I think you're interested in this area. If you want to pursue studies on at our university in Info-Bionics Engineering, you should have prior studies or strong background in one of the previous field, at least as a bachelor level. Biomedical engineering, bionic engineering, of course, it's a subfield of that, mechatronics, robotics, mechanical engineering, medical sciences, chemical engineering or medical imaging applications, computer science engineering. So it's, I would say it's a wider array of possibilities that we accept applications, but definitely we would need some preparatory semester in order for everyone to be on the same page, to know the same fundamentals that we can build upon in the Info-Bionics Engineering Master Program. So it's natural sciences, mathematics, economics and humanities, the side subjects, neuroscience and electrophysiology, electronics and computer science. So fundamentals in the preparatory semester. And let me focus on the Info-Bionics Engineering curriculum itself. It's a 4-semester master program with 3 main specializations. These specializations basically are the focus areas that are unique in a way, we can say that. Bionic interfaces, brain-computer interface, neural electrodes, optogenetics and multi-photon microscopy, prostheses. These are the subjects or the main areas or applications. Bio-nano sensors and imaging devices. As you know, larger and larger imaging devices are in the everyday use for diagnostics and therapy. Both the sensors and the devices and their multimodality are being dealt with during the lectures. Systems biology, which is a very exciting, as we see, new field in terms of modeling complex systems, coming from all the way from neural network, epidemiology, or even protein or molecular interactions, and accessing biological databases and understanding how these complex systems work. especially in biology. So if we look at bionic interfaces, what subjects or what focus subjects we deal with: signal processing, optics and microscopy, 2-photon microscopy, neuromicrosystems, sensory robotics and applications, neuromorphic movement control, and of course control theory for robotics. In bio-nano sensors and imaging devices specialization, we have more on imaging devices like ultrasound or MR or similar larger or smaller imaging devices. Multi-photon microscopy also as imaging, neuromicrosystems, nanotechnology or introduction to nanotechnology, and metamaterials and applications, of course, coming with signal processing as well. On the systems biology specializations, more on the data side, we do have some advanced statistics, data mining and machine learning, bioinformatics and systems biology, neuron and network modeling, and of course, using parallelism, advanced programming methods. So what are the applications or after graduation possibilities? What we see now is a very strong, not only research oriented, so we put a lot of examples here, like research institutes, mostly in Hungary, but it doesn't only, it's not only confined to Hungary, but all over the world you can find research institutes that work in biorobotics or rehabilitation engineering, university research laboratories that have this focus, and also large industry. We call it bionic industry, but of course it's biotech and medtech companies, a collection of biotech and medtech companies that are focusing on this interdisciplinary field of electronics, computer science, and biology, biotechnology, and their application. Some of them are Hungarian companies, some of them are international, multinational companies with very good background and strong research focus, as we see. And last but not least, an important possibility that we also try to help our students starting a startup or developing a startup idea and try to move in the biotech and medtech area, which is not the simplest of the startup areas, but definitely one of the most exciting areas that we see. We have a few examples here. Of Optoforce is basically a robotics company now. Mindtech, it started with an EEG headset development and application. Thermus company, it's an imaging device. Shaper 3D, I think that's it's already a known company. And Cytoplast, which is a systems biology based company spun out from our interdisciplinary field. And please check our homepage and Facebook page and check what we have to offer. And please listen more about the other possibilities that our university and that our faculty is about. Thank you very much.